We continue looking at implicit differentiation, and this was an example that we looked at in a previous video. Let's look at another example. Suppose you have a function that says x cubed plus y squared is equal to 7. Or say 7x to the 5th. Alright. Now, in that case, you want to find dy by dx. Now, let's see what would happen in this case. You have the derivative of each term with respect to x. Let me write this 5 a little clearer. Okay, good. Let's look a little better now. So, the derivative of x cubed with respect to x, so you say d x cubed by dx plus the derivative of y squared with respect to x, so you say d of y squared by dx equals the derivative of 7x to the 5 with respect to x, which is the same thing as 7 times the derivative of x to the 5 with respect to x. You see, you can bring the 7 at the front and just multiply, because it's not going to really change. It's not going to change the 7. So now, the x cubed by dx. When you differentiate x cubed using the power rule, remember, when you differentiate x cubed, you're going to multiply by the 3, so it's 3x to the 3 minus 1, because you're going to reduce the old power by 1 to get the new power. So what you have is 3x squared. So this becomes 3x squared, right? Plus d y squared by dx. How do you deal with this? Now, remember now that implicit differentiation is based on the chain rule, and you're going to have to apply it here. Remember the chain rule? You have a certain function, and then something is done to it, so you have another function. Right? So what you have is y squared. The inside function is y, and the outside function is everything here, y squared. Right? Now, it's the derivative of the inside function times the derivative of the outside function. You see that? So it's the derivative of y with respect to x times something is squared. How do you deal with differentiating something squared like x squared? When you differentiate x squared, you get 2x. So in this case, you're going to get 2. That means when you differentiate x squared, right, you get 2x. So when you differentiate y squared, you get 2y. Imagine it like this. Suppose I said, let me see now. Can I use back y? A is equal to y squared. And I want, in this case, the a by dy. The a by dy. I could say let u be equal to y, and a is u squared. The u by dy would be, the u by dy is 1. Right? And then the a by du, the a by du would be 2u So when I multiply them, it's 1 times 2u, which is 2u. Just explaining the chain rule part, equals 2 times u. But what was u? U was y, so it's 2y. Right? If you don't remember the chain rule very well, right, this could help you. But anyway, you can see that it's the derivative of the inside function times the derivative of the outside function. So you get 2y. Right? So, in this case, what you have is 2 times and then d by dx of y. Right? Now, you're going to get 2y. And then what you have is d by dx of something. It is y. So it's dy by dx. D by dx of y. It's the same thing I call dy by dx. So here, you differentiate 2y, you get 2y. And then you multiply it by dy by dx. Right? Equals, and then it's 7 times. When you differentiate x to the 5, you're going to get 5x to the 4 based on the power rule. 5x to the 4. Now, this is 3x squared plus 2y dy by dx. 2y dy by dx equals 7, 5, 35x to the 4th. Now, what is dy by dx? When you do your transposition here, what do you get? You get dy by dx equals, you're going to get 35x to the 4th minus 3x squared all over 2y. So you get 35x to the 4th minus 3x squared all over 2y. So there you have it. That's what you get.